Here's our job now. We've got a line and it's called L, and it has these parametric equations here. X is given by 1 minus 2 lambda, y is 3 minus lambda, z is 3 plus 2 lambda. Lambda is a real number. That's helping us get all of the points on this line. Our job is to find out, where does this line L intersect the XZ plane? So here's 3D space over here, and think about where the XZ plane is. It's all of this stuff. There is the XZ plane, and it extends, back into the page as well. So the thing that's going to be common to all of the points on this line, including the one, on this plane, including the one that we want to find, is that in each case the y value is going to equal 0, because we're stuck there on that particular plane. Okay, so that's our way of solving this problem. We're going to set y equal to 0, and look what's telling us about y. It's this second equation here. So if y equals 0, then it's got to be the case that 3 subtract lambda equals 0. Okay, and from that we can easily see that lambda itself must be equal to 3. Right, and then it's just a simple matter of plug in that particular value of lambda into all of the equations here, and we'll get what we want. So, well, hopefully we will. X is going to be equal to 1 take 2 lots of 3, which is minus 5. Y is going to be equal to 3 take lambda. Well, we've just worked that out already. That's 3 take 3, that's 0. And Z is going to be 3 plus 2 lots of 3, for a total of 3 lots of 3, or 9. So the point on this plane here, where this line intersects, is going to be minus 5, 0, 9. The point of intersection is minus 5, 0, 9. Okay, good idea now to jump into GeoGebra or your favorite graphing software and just confirm that that's the case. So what do we need to do here? We've got to put in the XZ plane. So the XZ plane actually has the equation y equals 0. Now we cannot see that very well here on this view because we're in 2D space. But if we go over here into 3D space, that's the plane that we're looking for. That's the plane that's described by the very simple equation y equals 0. Now, it might be a good idea to put in the line first. So how are we going to do that? Well, we need a point. Let's call that point A. And it's going to have coordinates 1, 3, 3. Now, what's the deal with that point there, A? The point A, I'm zoomed quite a bit out there, aren't I? It's not actually sitting on the plane, okay? Because it can't be, because it's got a y value which isn't 0. But anyway, that's the point that we're going to get when we set lambda equal to 0 for each of these. Okay, so that's going to be important. We also need to know the direction vector. I'll call it B, be consistent with what the textbook calls such things. And that's going to be minus 2, minus 1, positive 2. Minus 2, minus 1, positive 2. That direction vector there. Can I see it? Don't know actually. But anyway, we now have all the pieces that we need to get the line. So I'll use the line command here. And I want to use the point A and the direction vector. I'm calling it B, I think it was. And that is the line that's that we're dealing with in this particular problem. So there we go. It does cut the plane, that plane that we started with there. The question is, does it cut at the right point? Have we found the right point here? So obviously it's quite difficult to just eyeball it. the point that we thought it was, let's call it P, point of intersection P, was minus 5, 0, 9. How did we go? Yeah, it looks pretty good. It looks like that is actually the correct point there. Just so you know as well, GeoGebra has a really cool command to do this. So if we didn't know that point, we could work it out using GeoGebra by saying, let's find the intersection, or the intersect of two objects. So the first object will be the plane F, and the second object would be the line G, and that's going to be another way that we can find what it is that we want to find in GeoGebra.